Hey everyone, we still have a few minutes, so we'll wait until actual Berkeley time to get started. Why is there you go. But if you have any, pre-lecture questions or anything, feel free to put them in the chat. I'm going to put the Gradescope quiz link in the chat. It works now. You don't need to do anything until after lecture, but we might use a couple of the questions during lecture time. And here we go. Oh yeah, that's a good question. Is the range function similar as make array with NP a range? It's similar. It's a little bit different in that NumPy's functions they're going to return types that are specific to using NumPy as a library. So if you're using, all NumPy functions, then using np.arange will be, the one that you want to use. If you're sticking with built-in Python stuff, which is what we're going to be doing in CS88, then the built-in Python range function will be better. And the result that you get, in terms of the contents of that array will basically be the same thing. There might be a little bit of difference in terms of what they, some of the arguments, but start, stop, and step are the same. And I don't know if there's a difference in what step values you can provide, but for the most part, they'll work. In terms of giving you similar results. Cool, so it is 3:10, so I'm going to go ahead and share some PowerPoint slides if my computer cooperates, which is a big if. All right. Okay, PowerPoint just crashed, so we're going to try this one more time. All right, there is that. I'm going to go over to Zoom. Going to share, let's see, just share my whole desktop for now. And actually, let me move this over here so I can see chat. And there is no official group chat for CS88, but if there is something unofficial that you want, I would leave that to all the students to arrange for now. But yeah, so today's topic is going to be expanding upon the last two lectures. So last week we talked about higher order functions being functions that can return functions. And on Monday, the lecture was about lists, which are a really useful data structure that allows to just have a whole bunch of items grouped together, is the best way to think about that. So before we get into today, just some reminders. The practice questions still required. The first couple labs, the auto grading has been messed up. We're sorry that it's a little bit buggy, but the gist being, if you put in the token that it gives you back for the lab 2 or lab 3 or lab 4, whatever it is, practice question, you'll be getting the credit. If the auto grader tries to tell you that it's wrong, ignore the auto grader for now, and we'll fix it um, on the back end. But the auto grading itself is kind of a lie right now. But labs are mainly based on effort anyway. So as long as you're making effort, that's all we're looking for. Midterm again, October 7th in the evening. Going to be a similar deal to most of the other computer science STEM courses. We'll have some Zoom proctoring. Hopefully it won't be too intensive. Just your screen recording and a Zoom camera on your computer. You won't need a second device or anything like that. And if you do have a conflict with that time frame, we'll be releasing that conflict form again in a couple weeks, close to the exam. That could be due to another class. It could be due to being in an unfortunate time zone or taking the exam at an unfortunate time due to your time zone. There is no unfortunate time zone. No one should need to be up in the middle of the night to take their midterm. Is the gist of that. So before we get into today's actual topic, another interesting computing in the news story. So this comes from Dartmouth, and this is one of those really cool examples of combining computer science, data science, health sciences for a lot of really interesting potential work. And so this is using smartphone data to predict brain functions, which in this case are associated with anxiety and depression. And so this is the first study, or the first study that they claim of using data collected passively, so just by you using your smartphone to understand what's happening in your brain. And so they're combining this data, things like what apps you use, how long you spend on your smartphone. I don't know all the details. Perhaps when you were using your smartphone could be one of those things. But they're combining, they're combining that with MRI data, and they're trying to map what patterns they see from smartphone usage to patterns that appear in the brain that are backed up by MRI imaging. So the gist is basically that they're kind of early on in the study, but they're being able to combine multiple data sources together. And so that's just a cool thing. You can read the link and check out more of the details. There is what was I going to say? There's more in there about that, but this is one of those interesting things where what they're really trying to do is improve our understanding of how we use our devices, our brains, and how we compare that to medical images. A couple things from Zoom. I don't believe that Lab 2 may have not been given a token. If not, don't worry about it. This week's lab should. Lecture slides should already be linked on the website. You might need to refresh a couple times. In general, they'll be posted either right before or shortly after lectures. But they should be up there right now, if you would like. So today, what we're really going to be doing is combining our list knowledge with three common, I don't want to call them special, but they are higher order functions that appear in a lot of programming languages. So the three that we're going to be working on are map, filter, and reduce. And each of these has two arguments, really. One is a function and one is a list or sequence of data. And what we're going to be doing is combining them together, looking at how we can use functions as a means of creating interesting examples in code without too much extra work. So map is going to be this function that we apply a function and it gives us back a whole new list. Similar to a list comprehension, and you can think of them kind of interchangeably. Filter is going to be this cool thing which also returns a new list, but it lets us filter or remove data. And it could remove nothing, it could remove everything. That will depend on the function that you pass into it. And then the trickiest one that we're going to learn about is this function called reduce. And reduce is neat because instead of just returning a list, it combines the items of our list together using whatever function we tell it to. And so this can be a really interesting way. There's lots of problems that can be solved using reduce, some more clearly than others. And very likely it won't return a list, but it could. You could have something that combines lists of lists together into a single list instead of just a number or a word or something like that. But we'll see a couple examples of that. So before we continue on, actually, I just want to see, are there a couple questions about just lists or higher order functions in general? Anything that came up? Because the first thing that I would like to do would be if everyone can open up the Gradescope quiz. And let me just paste the link in the chat again. And just do question 1. You don't need to do the other 3 right now, but just do question 1, and we'll see after we get, I don't know if I have an easy way of telling exactly how many responses there are, but if we take a moment to do question 1, and I'm going to open this on my second screen, and we can see what the responses are like for that one. Let's see. And let's wait another 30 or so seconds and make sure that everything lines up. So question 1 is, we're going to explain exactly what's happening here. And I'm expecting most people to either get close or get it wrong. But one of the things that we want to think about is, let's actually just refresh this. And so, cool. So most people are guessing the right answer. And what we're going to do is sort of formally look at what's happening here. So what I'm going to do now is copy, let's see, just copy this over from another window and jump over to a Python interpreter. Yeah, so some good questions. So what's going on? Okay, why did my echo go off? With this function. So before we even get into how map works and how we can think about it, what's going on here? Well, we have a few we have a few components here. So we have range of 5, which again is worth remembering that. Oh, whoops. Let's try that again. We have range of 5, which is going to give us back a range object. And so if we ever want to look at a range, what we need to do is turn that into a list just to be able to easily see it. But it's the items 0 to 4. And why, again, why Python does this is it doesn't convert things like ranges into lists until it needs to in order to be particularly efficient. It's going to do the same thing with map and filter as well. So if we ever want to inspect the results or print them out, we'll want to call list. And then just to make sure that, no, not def, that we know this works, square is just going to multiply x times x. So what we have here is this function map. And if we didn't map, what would happen is we'd either just get a range back or we would get a list with some function in it. And so what map is going to do is take a function, whoops, in this case, if I can type correctly, which I can't today, square and some list. We can make this a range. We can make this any list on our own. And for each item, it's going to apply that function to that item in that order. Of course, because Python tries to be efficient, to see the result, we will again want to turn this into a list. But what map is really doing here is very similar to what we learned with a list comprehension. So let's call this square of x for x in range 5. And this would be the same type of operation as what with a list comprehension is what map would do. And for the most part, you can use them interchangeably from one another. There are a lot of different ways that you can combine them. Depending on the context, this list comprehension might be easier. Depending on a different context, you might find a use for the map function. And so it's just worth highlighting that in terms of tools, one is not necessarily better than the other. There is this word in the Python community called Pythonic, which is sort of like following Python style. And list comprehensions are a pretty common tool for that. But map still has its place. There's a reason it's built in to Python. That's a little bit about the theory of how map works. It's worth mentioning that with map, we can really put just about anything in our map function. So we're gonna use this function later, and it came up last week or on Monday, not last week, which is getting the first letter in a word. So if a word is a string, we can index strings like we can index items in a list. So if I ask for the first letter of, we can call it a word, CS88, I get the C. And actually, I'm going to make this a little bit bigger for the recording. We can ask really for whatever the word is. If it's hello, we should get back this lowercase h. And so when we map a function over a list, and this time I'll just do a list right away. Map first letter over, this could be our courses list again, CS88. Make sure I get the quotes right. Data 8 or 9, whatever we're doing. And we can just do 2 items for now. And close my third parentheses. We'll get the first 2 letters back. And so that's how map works. So any other questions so far on map? And let me take a look at the Zoom chat. Oh yeah, so that's a good question. What would happen if we did, yeah, so map takes a function and a list and it applies that function to every item and returns a new list. So that's absolutely correct. So what happens if we were to do something like square of list? Whoops, let me, so square of list, that's a really, really good question. So let's think about what's going to happen. Actually, I just saw before the closing parentheses was just because this parentheses closed the map and I hit enter. And so this one actually closed the list. So they just have to match. Yeah, so first question, what, and then we'll get to the one with map. So square of something like this list, does anyone, before I hit enter, let me get rid of that comma. Before I hit enter, does anyone want to guess what's going to happen if I try and do square of a list? So, so 1, 4 wouldn't return anything. Error, it would evaluate it. Does anyone want to type why they think it would return an error? And if you'd like, you can raise your hand or just unmute your mic as well. You're more than welcome to speak up. Yeah, cool. So error is the correct answer. And there's a couple of things in there about types. So typing is the right thing that's going on here. And we might think that it would just apply the function to each item in the list. But if we look at our definition for a square, okay, I have to go up a little bit more than I wanted. But all square is we're doing right now is, let's, so this is not something you normally do, but you can just write comments in your interpreter, which can sometimes be useful. So square is just returning x times x. So we could ask ourselves, if I were to do this, what should happen? Interestingly, in some languages, if I were to multiply two arrays like this, it might be reasonable to expect that I do some kind of matrix or vector multiplication. And in certain programming languages, that will actually happen, which is pretty cool. But Python is going to tell us that we can't multiply a non-int type with the type by the type list. So it's trying to tell us that there are some things that we might be able to multiply a list by, but in this case, we don't know how to multiply two lists together. In terms of, there's a really good comment there about square taking only one argument, and that is true. A list itself is also only one argument. So I could assign the variable a, not a great name, but it's short. I could assign a and pass square of a. That would still be only one argument. So sometimes the arguments line up and you could do that. But it's really useful as we're working through this to think about every time I have a function, we should ask ourselves, what is the domain of this function? So what are the inputs? The domain of square is a number, and its output or range is also a number. And so that's what we're working on there. And then there was another question about, let's see. Yep, so there's a comment in chat. So map square 1, 2 does the same thing as square of x for range in 1, 3. Yep, that's exactly correct. They are different syntaxes. In terms of, I will say, in terms of exactly, it's just to remember that map will return this map object until you call a list. So just be mindful of that. But the data that you get back will be the same. So yeah, there's another question here. What would happen if we assign map without a list? And this is the one difference where if I say data is equal to map of square, and let's do range of 5 again. And let's again close my parentheses and give us some more space. So data tells us that it is this map object. And one of the really interesting things about the way Python treats map objects, this is not something we're going to quiz you about in CS88, but it is just worth mentioning, is until I call list, what Python has done is said, I know that there's this map thing. And actually, let's do something else. So I could do something like this. For item in data, of course, if I actually type the word in, as I'm supposed to, for item in data, I can print item. And what we print back are the items of a list. And so sometimes we don't need to explicitly turn this into a list. If we're using a map in a for loop, if we're passing a map to something like a filter function later on, we don't always need to turn it into a list. Python is what Python is doing here is it first computes 0 squared, and then as it goes through each iteration of that for loop, step by step, it only then does it compute the square of that item. And when we're doing things like range of 5 or range of even 100 or 1000, it's probably not a big deal. But if we have 1 million items or 2 million or 10 million items, then you could do some really interesting things where Python is very fast at creating this map object, but it only then does the expensive computation right when it needs to. And so sometimes that can be a help there. Yeah, so what happens if we do square of a when a is equal to 1, 2? Yeah, that's going to be an error. So remember that I earlier defined a this way, and square of a is an error. And that's because it's still one argument, but that argument is now a, and a times a is the same as a list times a list, which Python doesn't know how to handle. Yeah, so what happens if we do a times 4? Well, the best way to figure out what's going to happen is to just try it. And Python does this weird thing where, I'll just move this up a little bit, a times 4 just repeats items of our list. So it will perhaps be a little bit more, if we have a 1 item list, and then I do a times 4, I just get the item back 4 times. If I have a 2 item list, it basically just ends up extending 1, 2, 1, 2. Why Python thought that was a particularly useful operation for multiplication, I don't know. I've honestly only ever done this in examples. It works. It's defined behavior. You can duplicate a list that way. You might have a need for it, but that's really just something that Python decided it wanted to build in. I personally think it's a little bit weird and unexpected, but hey, it works. It does something. Yeah, so why doesn't it multiply 4 across the list? The developers of Python basically thought that, extending a list, I guess, would be the more common operation. If we're talking about data science-y things, then doing a vector style operation would, I think, be much more useful. But that's up to each programming language to decide how they want to build it. So moving on, what I want to get to next is the function filter. So filter is one of those things where, again, this is of our 3 harder functions, this one is also built in. And we have our list comprehension. So actually, before we do our list comprehension comparison, let's just try this. So let's say we have, and I'm going to, again, turn this into a list. Actually, let me do this first. We need a function that we can use to filter our data. So like map, we had a function called square that could have been a function add 1. It could have been a function, first letter, and so on. So in this case, we're going to have a function, and let's just call this big. And actually, no, let's not do big. That's a little bit less interesting. Let's use the function even, because this is continuing an example that we've done before. And if a number is even, n mod 2 is, oh, whoops, not that is equal to 0. So we can just double check. Even of 4 is true. Even of 5 is false. So that is, this is one of the standard checks for even. But what do we want when we're talking about filtering items in a list? Well, in a list comprehension, we have this if condition. So if something is true or false, what we're going to do is we're going to think about how we can filter and keep items. So a filter looks much the same way as map, but instead of a map, we're going to use the function filter. And the function that I'm going to use in this case is even. And what am I going to filter over? Well, let's say range. In this case, I'm going to do 10. So this is going to give us back the values 0 to 9. And filter does this thing where the resulting list has only the items that match where that function is true. So what I should expect to get back is 0, 2, 4, 6, and 8. So this is the exact same setup as even of x for x, or actually, sorry, not even of x. That would not be the same. X for x in range 10 if even of x. And so you can kind of see that one of the reasons that some people like using higher order functions like map and filter, even though you have, typing a list, to some people it is just a little bit more readable that we're filtering this thing on the function even. X for x, it can seem a little bit weird. After you read list comprehensions, you'll get used to something like this as a way of filtering data in a list. Again, what you prefer is really just a preference in terms of which of these two seems more readable to you, but they do the same thing here. And so filter is our other function that of the higher order functions. And so one of the examples that we're going to do today is okay, and my K key is annoyingly having trouble, is we're going to try and get the acronym UCB from the sentence, the University of California at Berkeley. So NIA at, come on, K. So we have this this sentence, the University of California at Berkeley, and we want to filter out all of the unimportant words. So we're going to make a function, and we're going to call this important, and it's going to take in a word, and we're going to return if I. Does someone want to suggest what might be an interesting condition to decide whether or not a word is important in our function to get the letters UCB out of the sentence, the University of California at Berkeley? Thinking about just a word. So capitalization is a good guess. We don't want the word the. Yeah, length. And what might be a good length condition? Even words. That actually works in this case, but is not quite what we want. Yeah, so greater than 3. So yeah, we haven't done this yet, but length of word is in the same way that you do it on the list. We'll do it on a string, and length of word greater than 3. So important course, it's a thing. Let's just make sure the is not important, which is basically true. And, and California is an important word. So that is, that's good. We're going to have a way of filtering things. So what I might want to try now is filter on important over my variable Burke. Will this work? If I'm about to do filter important over the sentence, the University of California at Berkeley, do we think that this will work? No, perfect. Why not? Yeah, it's not a list. And that's exactly the right answer. In this case, we don't get an error back, which is a little bit confusing in terms of what Python does. So sometimes one of those things where we're going to have to think about when something is unexpected, why is that happening? But we don't get a list back, or we don't get the data that we want back. So in this case, we want to turn this variable into a list. So what I'm going to do is I'm going to set this to words, and we're going to split on a space. Whoops. So this is, again, one of those functions that if you need it on an exam or lab, we would tell you about it. But you'll just build up the list of functions that exist over time. And so split does this really cool thing where for any sentence or set of words that we give it, we can split by different things. We can even there's this cool case. If we split by, wait, why didn't it like? Oh. Why did it not like this? Okay. Okay, so I have to figure out what I was going to do no longer works in Python 3. This used to work. There's a really easy way as well, but I now forget to split by each letter. But you can also in split, if you don't want to split by space, the default argument to split is splitting by space. But most often when you want to split by space, you will just explicitly say split by space. So perils of live demos, sometimes I forget what the argument to a function is, but that's okay. We have our list of words. So what we can do now is filter our list properly. So we have filter. The function, again, is the first argument. Important. We have our list of words. And we get University, California, and Berkeley. So what we get back from this is is a list. And now we've done one of the steps in getting an acronym. Yeah, so filter like map also returns a filter object. It does this, again, in the same way to save computation until it needs it just in the amount of time. So we've done we've done map. We haven't talked about how map will come into this task of creating an acronym. And just so it's clear, this acronym that we want is going to be equal to UCB. So one thing that we'll notice, though, is we have this list, and what we also want to be able to do is to get back to a string. And I'm just going to clear the screen. Getting back into string, combining data, there's a few different functions we can use for that. But there is another higher order function that is one of the many ways that we can we're going to use another higher function that lets us combine things together. Before I continue on, I shouldn't read chat while in the middle of speaking, but with only filtering without list, will Python return an error? So in this case, no, Python will not return an error. This expression is still a valid expression. Filter is still its own object. It just hasn't actually computed the result yet. So when we ask for a list, we're telling it, turn this filter object result into an actual list. Interestingly, in Python, I can do list of, well, just a list. And I just get the same result back. But what's worth thinking about is when you ask yourself, is an expression going to return an error? Python evaluates things from the inside out. So first, it makes sure that this filter works, so that has a result to pass to the list function. And so if there's sort of an outer function call that happens, so at the point that we got an empty list back or that we got some data back, that means that everything else on the inside at least didn't error. Maybe it didn't give us the exact result that we wanted, but if we ever get to a certain point and we don't see an error, that means that that content or that function alone won't cause its own error. So we can, like in map, we could write a for word in this filter function if we wanted to without turning it into a list. But I'm not going to do that right now, just so we can get through the main example. So the last piece we're going to introduce is this function called reduce. And reduce, of course, if I type this correctly, reduce lives in this Python library or module called functools. And what it does is it's going to let us combine items of a list together. I'm also going to import from operator, import, if I type import correctly, add, mul, min, whoops, no caps lock, min, max, sub, and concat. Oh, we don't have min and max. Oh, because min and max are built in, right? Yes, they are. All right, so let's just redo this to make sure we have everything we need. Cool. So this just gives us a few built-in functions that are not terribly interesting, but really handy. So add, 1, and 5 is a function that just adds our numbers. Multiply and sub do the same thing. Concat stands for concatenating strings. So if I were to put A and B together, all it's going to do is combine these two things. And this will be a useful example for our reduce function. And so how does reduce work? So reduce is the most, I think, potentially confusing of the higher order functions. So reduce is going to take in some function, and for now I'm just going to use add. And I'm going to use a list of 2 items. And what reduce is going to do is it's going to take the first item of our list, and then it's going to combine that value, calling that function with the second item. So we have, by reducing with add, we've combined 1 and 2 together. We can reduce with 3 and we get 6. So with add, what this really says is, add up all the items in our list. Reducing over add is not something you would do because there's a built-in sum function, but this at least illustrates what we're thinking about here. And so how does this work really? So essentially what we're doing is we have add 1 and add 2, which this gives us back 3. And with 3, this example is not super clear, but we're going to take that first 3, and then we're going to add the 3 in our list. So that gives us 6. And if we had, a million items in our list, we'd add the first 2, we'd get 1 value back, and then we'd add that value to the third item, add the results of the first 3 to the fourth item, and that result to the fifth and sixth item, so on. So add sort of starting with the first pair of items, or reduce starting with the first pair of items of our list, sort of walks down our list and combines them together. So we can reduce with really just about any function that takes in 2 items here. So we have concat, and we have our list of letters. So A, B, and let's do C. And what we get back is A, B, and C in that order. And so reduce is really nice in that, in this case, the order really does matter. Otherwise, things would be shuffled. So it's just going to go from left to right, top to bottom, whatever you want to think about a list being in that structure, and combining the items together. So what I want you to think about now, and let me swap over to my browser. And in Gradescope, the third question called in what order, I want you to take a guess at in what order are we going to do our acronym function. So I will, in an interpreter right now, I'll remind everyone that we have 3 functions. So we have first letter of Berkeley, and that gives me back a B. I have important of a word like at, and then we have our concatenation of any 2 strings, and that will combine them. So we have 3 functions, and by having these 3 functions, you can probably guess that we're going to each be using map, filter, and reduce. The question is, what order do I need to combine these in to properly produce an acronym? So let's take a few moments and answer that question, and then we'll look at, we'll try this out. And let me see. All right, let's take, let's see. Let's take another minute or so and see how we're doing here. Yeah, if you get it right, the explanation, the correct answer will be will be shown with an explanation after lecture. But you can also just guess multiple times. The order really matters. So the phrasing that I was expecting for the question, in case this is confusing, is the innermost one will be first in the list. So if we were going to map first, it would be map, then filter, then reduce. If we're going to map last, then map would be the third thing. So the order that you describe doing things is kind of an inside out order. I also got a good question privately, which is how is reduce different from join? Reducing with the concat function is very much a similar way of using string.join with some list. But they both are a little bit different in how they work. So there are a lot of different ways that we could write this acronym example, including using list comprehensions and the join function. So, you know, if you're thinking like, well, I've seen this join function, I've seen list comprehensions, do I need this stuff? There is another way of doing it, but today we're going to do the higher function way. Yeah, and with reduce, you need to, from func tools, FUNC tools, import reduce. Of our three harder functions, it is the one that is not built in. So let's go back to Gradescope. And cool, so as I was talking through that, we went from like 10 or 15% to about 50% correct. So this one is definitely worth thinking about for our order of what we want to do things here. So we're going to talk through this, and we are at 4. So if you need to drop off, no worries. But we'll just spend our last minute doing this. So we have some words, and initially we feel like we might want to map first letter over our words. And actually, let's just turn this into a list. If we map first, what we realize is we're going to throw away some of our information that we need. So importantly, we defined the important words based on length of our word. So in our example, with our functions, we're going to need to filter first so that we don't throw out that information yet. So we'll get to an example of reduce. And if you want to hang on after lecture, I can go through a couple more examples. But if you have to go, no worries. This recording will be up later today or tomorrow, whenever it finishes processing. So what we first want to do is, and we'll try this, we'll combine these first two. So we know that we want to filter first on our function important and over our words. So if we filter first, it's going to be the inner thing, and what we do next is then map, and you can have extra spacing. This might look a little bit weird, but just typing this in the order that I want to say things, I'm going to have some extra spacing here. So ultimately, right, we're just going to get our list. We want to filter first, and then what we want to map is first letter. And so if we map first letter over the filtered list, we've got our three important letters U, C, and B. So what we can do instead of turning this into a list is reduce. So if we reduce with our concat function, which combine, whoops, I did not mean to do that. We'll retype that. If we reduce with our concat function, actually should be right, then we've combined our list back into 3 items. So we're going to filter first, then map, then reduce. Is the order that that we were looking for on that one. And that is how we go from a sort of list of words to combining them back into one acronym. So the question of what reduce does. So we can think about it this way, is that our concat function combines 2 items together, right? It combines A and B just by stuffing them together. When we reduce over a function that takes 2 items, we're going to successively combine our data. So if we were to, so let's say, I'm going to call this letters is equal to A, B quotes, and C. What did I? Why didn't it like my? Why? What don't you like about my syntax?
Professor, I think it's the quotation mark.
Oh.
On the A.
Oh, on the A. Thank you. I was like, which one of them is missing? Cool. Yeah, so now we've got a list of letters. And when we reduce, so if we reduce with concat, we're going to get A, B, and C in that order. So what this is really doing is we're just going to call this step 1 is equal to concat of letters. So this is going to be more to type, but that's okay. Letters 0 and letters 1. And so S1 is our first step of this reduce operation, is the string AB. And what our second step is going to be is equal to concat of S1 and letters 2. Of course, if I spell the function correctly, then our step 2 is A, B, and C. And with only 3 items, there's only 2 steps in the process of reducing this entire list of 3 items together. So we can verify reduce concat letters, and we have A, B, C. If we had, this is not going to work because I don't have that many items. But if there were more items, we might have something like concat of S3 letters, or sorry, not S3, or yeah, S3 would be concat of the S2 operation, the next item in our list. If we had 4, then we'd be combining the previous step with the next item and so on. And so what concat is what reduce is doing is for any function, in this case, we're doing 2 strings at a time. If this were a list of numbers, we could be adding 2 numbers at a time or multiplying 2 numbers at a time. We're going to be combining them together into singular values. So what reduce does is, yeah, you could concat on the list ABC like that. Yeah. So, yeah. So that's a good question. Why did the last line with reduce not require us to return a list? That's because what reduce returns is the essentially a result of the way that we concatenate or whatever function we're using. So in this case, if we're using concatenate, reduce is going to give us something back that's not actually a list. It's going to be a string in this case. What this does mean is that the second that you hit that reduce function, Python will immediately execute and try and process your data. So it is not the word that we can use lazy in the way that other functions like map and filter are lazy, but is also a reason. But more importantly, it's that what reduce will return is not always a list. And in fact, if you're doing things like summing or multiplying numbers, or if you are looking for some item, then you can you won't necessarily get back a list. So one thing that's another example that we could do really quickly is we could do something like reduce over min. And if we have 10, 11, 15, let's say 5, 9, 12, that's a good enough list. We have a function min, which takes in two items, 10 and 11, and it's going to keep giving us the minimum item of two item comparisons until we process everything in our list. So min of 10 and 11 is 10. Min of 10 and 15 is 10. Min of 10, and I'm just going to go, I'm just going through this list in order, and 5 is 5. And so this is our actual answer. Of course, we don't know that yet because we haven't compared every item in the list, but min of 5 and 9, is going to be 5 again, and min of 5 and 12 is 5. And so what reduce is doing, this is another way, instead of building something up where we're sort of still looking for only a single value, but what we're doing is pairwise comparisons of these two first items, and we get some result back here. And then we compare this result with the next item in the list. Then we compare that result with, again, the next item, and that result with the next item until we've compared a result with every item in our input list. So that is another example of how reduce works. Let's see. Yeah, can functions that take in a list take in a map or filter object? That is a really good question. The answer is, in most cases, yes, they can, but not in all cases. So it really depends on what's going on with that function. Most things in Python, we have lists. We'll talk about later this other data type called a tuple, which is a list that you can't change. We have ranges. These are all map and filter as well are sequences. And so most functions can operate on something that is like a sequence, but not all of them. And so Python does make it pretty easy to write functions that without any extra effort will do the thing that you expect. So you can use a map in most places that you can use a list. But I don't want to say every single place, because every once in a while you will encounter a function that prevents this from happening. Cool. So, and yeah, so is reduce typically most useful with concat? So reduce is probably, it's concatenation in Python has other uses. Um, so there are other ways. Using string.join is a common way if you need something more advanced. So you will find that in Python itself, reduce is not a super common function. Using something like a more advanced version of a min function, where if I were doing this on my own, I would use Python's built-in function min, because min min whoops works on a list of data. Reduce is really useful though when you're combining just certain kinds of data together. So whether that's specifically combining strings, there are versions of reduce that work in a slightly different way, but you might combine files together. Really, it's any kind of operation that works on two pieces of data at once are places where reduce will come in, which is a little bit of an abstract answer. But whoops, I did not mean to paste that in. Yeah, and then the question, let's see, last thing before I have to go, 2.2. So these will all be out after lecture. 2.2 is an interesting question on the quiz, and it will be there'll be a written explanation there. But 2.2 is asking what type of functions are valid to pass into a filter expression, and there's really from what we saw with filter today, there's two things that filter needs as a function. It needs a function that takes in an item so that we can compare, we can check each item of our list, and it needs to return a true or false value. So our function A doesn't take in any item, so we can't effectively filter on that function. Is the reason that A is not a valid function for our filter expression. For B, it takes in this value x, it returns x is greater than 20. So it takes in a value, it returns a Boolean. That's a very common function that we might filter some data on. And then function C in our example takes in a parameter y, and it just returns false. So this is not exactly a common function that we would use, but for each item in our list, we can call C with the item. So we could say C of 10 or C of Berkeley, and that C function will just report false. And so what a filter function that always returns false will do is it's going to give us back an empty list, but it is a valid function for a filter expression. And yeah, that will be it for today. I do need to prep for another class, so thank you, everyone. And we will see you live next week, and then Monday's lecture will again be recorded.